I am Anil Kumar. Welcome to my series on conic sections. In this video, we will understand what really parabolas are. We'll kind of define them, look into their standard form of equation, and also the transformed form of parabola. From these equations and the characteristics, we are going to find the vertex, focus, axis of symmetry, and the directrix of the parabola. As you can see in the illustration, parabola is loci of points which are same distance from a point and a line. The point is called focus, which is shown here with F. And the line is called directrix, which is shown in green. Now here you can very clearly see that the point P on the parabola is same distance from F, the focus, and the vertical line PM. The vertical line is called directrix. Now the parabola shown here opens on the right side or on the left side. So that is one way it can open. The other way is that the parabola can open up or down. So we'll look into these four conditions. Let us have a closer look at the point on the parabola. In this part of the video, we have fixed the focus F, and now the point is moving independently along the curve. As you can see very clearly, the distance of the point P from the focus F is exactly same as the distance from point P to the vertical line directrix PM. So that is the major characteristics of parabola. Now based on this characteristics, we are going to define the equation of parabola and understand it to a greater detail. Before we get into details, let us try to understand some basic definitions related to parabola. As I said, conic section with locus of points which moves in such a way that its distance from a fixed point focus is exactly equal to its distance from the fixed line directrix, all being in the same plane. As is shown here, we have a fixed point P, the point P on the parabola, which is at the same distance from a fixed point F, the focus, and the line, which is directrix. Now, if the parabola opens sideways, in that case, the line will be vertical as shown here. As you know, parabola can also open up or down. So we have four standard equations for the parabola, depending on its direction of opening. Focus. Focus is defined as point about which the rays reflected from the surface of the curve converges. It really means that if we have parallel rays, let's coming, for example, they will all go through F, the focal point, right? So that is how the rays will be reflected. So if there is a ray which is parallel to the axis, then it will be reflected through the focus. So that is how we define the focus itself. Directrix is a fixed straight line as shown here, and the condition is, as we have said, the distance of any point on the parabola, which we have P here, from the focal point F is always equal to the distance of the point from the straight line, which we have shown as Pm in this particular figure. So this distance is same as the other distance. That is called the focal length. Perfect. Now in conic sections, it is a characteristics that the locus of points which we talk about have a constant ratio of distance from a fixed point, which is focus, to the fixed line, which is directrix. Now this ratio is 1 for the parabola, and so the eccentricity is 1. Eccentricity is defined as a constant ratio to the distance from the point to the focus and directrix. Eccentricity E is 1 for parabola. Axis. Axis is a straight line through the focus and perpendicular to directrix. So in this particular case, the axis is the line which is shown here, which passes through the focus and is perpendicular to directrix. So I hope this basic scenario is clear. Vertex is a point on the parabola which intersects where the curve and the axis intersects, as shown here by point V. Very interesting fact about parabolas is that they actually have two real foci on its axis, one of which is at F as shown here, and the other one lies at infinity. The other directrix also lies at infinity. So parabolas actually have two foci and two directrix. I'll also define some chords in the parabola. Well, as you know what chord is, chord connects 2 points on the curve. Now, we're talking about very special chords in this case, which are perpendicular to the axis. So the chord here from P to P dash is called double ordinate. Double ordinate is a chord perpendicular to the axis. A special case of double ordinate which passes through the focus is called Latus-rectum. Latus-rectum is the double ordinate passing through the focus. Latus-rectum is the double ordinate passing through the focus as shown here, L dash. We'll also work out a formula to represent its value. Now in general, we'll first begin with standard form of parabola. When we say standard form, what do we mean? We mean that the vertex will be at origin, right? So in standard form, the vertex is going to be at the origin. So I'm taking a case where the orientation is that the parabola is opening right, as shown here, right? So this is opening in the right direction. In that case, the axis is y equals to 0. So this is the axis which is y equals to 0. The x-axis is the axis of parabola which opens right or left. Directrix, the line, which in this case will be parallel to the y-axis, same distance away as the focal point from the vertex. You see that? So that is the directrix point. So as you can see, on the axis, the vertex is midway between the focal point and the line itself. Latus-rectum, whose length is shown as L to L dash, passes through the focus as I just defined. Now we'll relate all this and soon we'll prove that if P is the distance from the vertex to the focal point, in that case, P is also the distance between the vertex and the directrix, correct? So this is 2p, as you can see here. P and P becomes 2p, and therefore the distance from L to F should also be 2p. So that added to another 2p from the symmetry of the parabola, we can say that the length L to L dash is 4 times p. You get the idea. So Latus-rectum length is always 4p, where p is the distance from vertex to the focal point, the focus. Perfect. Focal distance p to f is equal to p plus x. As you can see here, focal distance p to f, which is from here, any point on the parabola, to the focus. So that distance is equal to the same distance as from the vertical line. So this is p plus x. You get the idea, right? So that is the focal distance. And so we can say that the focal distance is equal to this horizontal distance p plus x. And so we get another very important result, that is the focal distance is always equal to p plus x. We are talking about standard form of parabola where the vertex is at the origin, right? Remember, if the parabola is translated, in that case, we'll have to take care of the transformations. Now we'll soon prove the equation representing the given parabola. It is y square equals to 4px, or it can be written as x equals to 1 over 4p y square, where the stretch factor a is equal to 1 over 4p. So that is the equation which we are interested in. So let us derive this equation now. Okay. So here is the derivation of the equation for a standard form of parabola. So here, to derive the equation, the basic concept is we'll consider parabola with the vertex at the origin. So that gives us the standard form. So that is the vertex. Directrix will be at x equals to minus p, since the distance between the vertex and the focal point is p, right? So p is considered to be a distance between vertex and focal point, and therefore the coordinate of focal point, which is on the axis, this is the axis, correct? Y equals to 0 will be p0. It is p units to the right in this case, and therefore the distance from the line, the vertical line, will also be p, and therefore we have the directrix whose equation will be x equals to minus p. So this equation of the vertical line is x equals to minus p. Is this part clear? So basically we are saying that from the vertex focal point and the line, vertical line, directrix, are same distance away. So if p is the distance between V and F, then p is also the distance between V and the line. So that is how we get the equation of the directrix, which is x equals to minus p. Clear? So what we've got here is a point on the parabola. Now this point has to be same distance away from the fixed point focus and the line directrix. So these two distances are equal. So that will help us to get the equation. So we know that PF, distance of the point xy from the focus F, which is P0, Pm is the distance of point P for the directrix. Pm is the distance of point P xy for the directrix x equals to minus P. Now from the property of parabola, we have Pf equals to Pm. Now, how do we find P to F? Well, we are given the coordinate points, P being xy and F being P0, so we'll use the distance formula. Well, it involves square root. Why not square both sides? So if Pf equals to Pm, in that case, Pf square is equals to Pm square. And Pf square is basically the distance between the coordinate points of P and F, x minus P whole square plus y minus 0 whole square. So that is our left hand side. As far as the right hand side is concerned, P to M is a horizontal distance which is P plus X. So we have X plus P whole square on the right hand side. Simplifying, we get y square equals to x plus p whole square minus x minus p whole square. Well, you can expand both these expressions and simplify. X plus p whole square is x square plus 2px plus p square minus x square minus 2px plus p square. That results into 4px as x square cancels with x square, p square cancels with p square, and we are left with these terms 2px minus 2px. So that becomes 4px. So we get the equation of this particular parabola, which is y square equals to 4px. As you are also aware of general equation as y square equals to 1 over ax, we can say that a equals to 1 over 4p. Perfect. So that is how they are kind of related. So what I have done here is also reorganize the equation in different ways. So y square equals to 4px. I could also write this as isolating x from here. So we get 1 over 4p times y square equals to x. You can see that, right? So that means x is equals to 1 over 4p y square, and that gives you the relation which I'm talking about, and that is the amplitude, the vertical stretch factor is 1 over 4p, right? So we have also derived another very important result here, and that is that the vertical stretch, which normally is written as a, is equal to 1 over 4p. Is that clear to you? Right? So that is going to relate to the vertex form of parabola later. Correct. So I hope you have understood how we have derived the equation of parabola in standard form, where the vertex is at the origin. Perfect. Now, as far as parabolas are concerned, we could have four different orientations of these parabolas. Based on that, the standard form of equation, which we derived as y square equals to 4px, can be written as four different forms. So the first one is y square equals to 4px is the case when the parabola opens right, correct? Now it could have open in the left side. In that case, it will be minus 4px. If it opens up or down, in that case, what happens? If it opens up, in that case, x square equals to 4px. We are going to swap x and y to get our equation. And if it is opening downwards, in that case, we'll have the minus sign. X square equals to minus 4py. You get the idea. So those are the four different conditions for the parabolas, right? So let me just sketch them here for you. So we could have a parabola which could be opening right or left, or it could be going up or opening down, right? So those are the four conditions which we are talking about. And with respect to these four conditions, we have these four formula, right? So 1, 2, 3, and 4. Clear? So that is your 1, this is 2, this is 3, and this is 4. Now in each case, we have a table here which gives you what could be the value of the focus, the equation of the directrix, the axis equation, what will be the length of Latus-rectum, and what is going to be the focal distance. So this table helps you summarize all these parameters. So for example, if a parabola opens left, in that case the equation will be y square equals to negative 4px, right? Vertex being at 0, 0, but this time since it is opening left, the focus point will be on the left side. You get the idea, right? So it will be minus p0. Correct? Directrix will be on the right side, so that will be x equals to p. The vertex being in the middle of the two. So the average value of the vertex is going to be 0, 0 to begin with. Clear? Axis is going to be parallel to the x-axis, and therefore the equation will be y equals to 0. And Latus-rectum, as we discussed earlier, the vertical chord which passes through the focal point will be of length 4 times p, and the focal distance will be p minus x. Now, what is focal distance? Again, a reminder, focal distance is the distance between the focus point and any point in general on the parabola. Clear? So that x value will be subtracted from p. So likewise, we have a table here to summarize all the related values depending on in which direction the parabola is opening. Now based on this, we have our first example. The question for you is identify vertex, focus, axis, directrix, and Latus-rectum for the parabola y square equals to minus 12x, and then sketch the graph. So now we are given the equation y square equals to minus 12x. How will you sketch this graph? Well, for this equation, it's a standard form. We know that the vertex is going to be at the origin, correct? Now, since it is minus 12x, it should open in which direction? It should open towards the left side. You get the idea, right? It opens towards the left side. Now, first thing first, we should find the value of p, which is the distance of the vertex from the focus, correct? How can you find that? Well, easy way is to look at our standard form, which is y equals to 4px. So if you compare them, you can see that 4p is equal to minus 12, and that means that p value is minus 12 over 4, and so we get the value of p as minus 3. Now, since p is minus 3, now in this case it is opening towards left, so we have a focus point which will be at minus 3. So from 0, 1, 2, and 3. So that gives you the focus f. You get the idea. So we have the focus. Now directrix will be on a line same distance away. So since this distance is going to be same between the vertex and the focus, that will be at 3, correct? So directrix will be a vertical line as shown here, and the equation of this will be x equals to 3. Perfect. So that is how you get the value of directrix also. So we got the vertex. Vertex for us is 0, 0. Let me rewrite. So we have vertex 0, 0. And then focus is at along the axis, and axis is y equals to 0, right? Along the axis at -3, 0. So we got the focus. Now directrix is the vertical line. Directrix will be what? So directrix will be the vertical line as shown here, x equals to 3, correct? Latus-rectum, as we said, is equals to 4 times p, but it is always a length which is going to be positive. So let me write down in short, latus-rectum will be equals to 4 times p, and in this case it is going to be 12. So we'll not write negative. Latus-rectum is 12. So from F, we'll go 6 up and 6 down to get 12. So almost kind of like this, going beyond the scale, right? This is 4, 5, and so like this, correct? So that becomes our parabola, right? So you can actually see how we could sketch this particular parabola, right? So it is going to be kind of like this. Do you see that? So we get our parabola as shown here. And we have already found what is the vertex, what is the focus, axis, directrix, and the latus rectum for the given parabola. Perfect? And that is the directrix, which is 3 units to the right of the vertex, vertex at origin. So we have sketched it rough. To do a better job of sketching, you could actually consider few points. So you can make a table of values. We know y square equals to minus 12x, so take some values of x. Now clearly the x values could be negative only, right? Because it is opening towards the left side and square root of negative numbers is not possible, correct? And therefore, what we have here is we can start with 0. If at 0 we have 0, if I take 1, in that case 1 will be square root of 12. 2 will be square root of 24. 3 will be square root of 36, and that gives you the value at 6. And so that is the point which we are looking into. Remember, it is going to be both plus and minus 6, right? How do we get that? It is from the symmetry. Y square is minus 12x, so y is equal to plus minus square root of minus 12x. You get an idea. So when we are getting these values, they will be both positive and negative, correct? So they will be both positive and negative, and these values when plotted will give us the graph. Perfect. Here is the neat solution for the same. As you can see, here, we have taken the standard form of the equation, which is y square equals to 4px. The equation given to us is y square equals to minus 12x. Comparing 4p with minus 12 gives us the value of p as minus 3. So that is the distance between the origin and the focus. At the origin, we have the vertex. Vertex is at the origin 0, 0. So this is vertex for us. Axis is the x-axis whose equation is y equal to 0. Directrix is the vertical line whose equation is x equals to 3, which is same distance away as the focus but on the other side. Latus-rectum is 4 times p, whose value is directly given as 12. Now to sketch the parabola, what we need? We need to find some values of y from the values of x. So if I do square root with plus and minus values, x has to be less than or equal to 0. Substituting few values of x, we can actually calculate the value for y. Plotting these points on the graph, we will get our results, and so we can sketch the graph. So I hope the whole process is absolutely clear. So what we have done here is that we have identified all the important parameters of the parabola from the given equation. Now let's look into another example. So this time it is x squared equals to 16y. The question here is identify vertex, focus, axis, directrix, and the latest rectum for the parabola x squared equals to 16y, and then sketch the graph. Now when I say x squared equals to 16y, in which direction is this parabola going to open? Well, clearly, this time what we have is a parabola which is opening up, right? So this is a parabola which is going to open up. So when it opens up, we'll have a directrix which will be on this side. You get the idea. Focus will be here. Along the axis, we'll have the focus same distance away as the directrix, right? So that is going to be the position, right? So vertex, and let me call this point as D on the directrix. Is that clear to you, right? So how should we go about? Well, we have the equation x squared equals to 16y. So clearly, this is the standard form of equation where the vertex is at 0, 0. So we have the point right there at the vertex. Now, we can compare this with the equation x squared equals to 4py. And that means 4p is equal to 16, or the value of p is 16 over 4, which is 4. So therefore, what we have here is p, which will be 4 units above. So 1, 2, 3, 4. So that becomes the focus for us. So directrix will be 4 units on the other side. So 1, 2, 3, 4. So this horizontal line is going to be the directrix for us, right? Whose equation will be y equals to minus 4. Perfect. The focal point will be at 4. So we get all these points. Now from here, we have found the vertex, the focus, axis, directrix, and latest rectum is actually equals to 4p. So latest rectum will be equal to 16. That really means that the distance from the focal point to the one side is 8, on the other side is also 8. You get the idea, right? So this is how the graph is going to be. So this is a smaller portion. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, kind of here, right? 8 on this side, 8 on the other side. So that is how the parabola is going to look. So what you could do is, let me just sketch roughly here. Correct. So that is how the parabola is going to be. But to find the points exactly, what we can do is we can again form a table. And in this table, we can put some values for x and calculate y or the other y, right? So either way you could work out. So taking the values of x as, let's say, 0, we get y as equals to 0. And if I take x as plus or minus 1, in that case, y will be 1 over 16. If I take the value of x as plus and minus 2, so it will be 1 over 4, right? If I take plus and minus 3, so it will be 3 square is 9. We can get 9 over this. So plus and minus 4 is going to give us the value of 1. You get the idea. So at plus and minus 4, we get the value of 1, 1, 2, 3, 4. So that will be a point on the parabola, and this will be a point on the parabola. Based on this, we can actually roughly sketch our parabola. Is that clear to you? Correct? So that is how the graph is going to be. Now let us look at the complete solution. So we need to identify the vertex, focus, axis, directrix, and the latest rectum for the parabola x squared equals to 16y. And then we are going to sketch the graph. So standard form of the equation is x squared equals to 4py. When you compare it with x squared equals to 16y, we know 4p is 16, and therefore p is equal to 4. Now what is P? P is the distance between the vertex and the focal point. In the standard form, we know that the vertex is at 0, 0, and the focal point for a parabola which opens up will be p units up, and therefore it makes sense to write the focal point as 0, 4, right? So at 0, the focal point will be 4 units above. So that becomes the focal point as you can see here. So this is basically 0, 4. As far as the axis goes, axis is the vertical line shown here in as the y-axis. So equation of the y-axis is x equals to 0. So that becomes the axis for us. So this is the axis, x equals to 0 is the axis for the parabola. So when I say axis, it really means that there are points which are symmetric about it, right? It makes sense. Since we have x squared equals to 16y, what is x equals to? Well, x is equals to plus minus square root of 16y, or it is equals to plus minus 4 square root of y. So for every value of y, we have two values of x, as you can very clearly see from here. So if I have a value of y, let us say at 10, we have two different values of x as shown here. So the axis is symmetric, and we have 2 points as shown by the equation right there. Directrix is same distance away as the focus from the vertex, and that becomes the directrix, which is a horizontal line y equals to minus 4 in this case, since it is below the vertex by 4 units. So that is how we do find it. Now, what is Latus-rectum? As defined earlier, it is a chord which passes through the focal point, and the length is 4p. As we know, 4p value is 16, and therefore the length of the Latus-rectum is also 16. So that means, as you can see here, this point and those points will be minus 8 and 8 away to give you 16. So that becomes a very critical point on the graph of the parabola, which helps us to sketch it. So we have the vertex and we have the Latus-rectum, but to accurately sketch the parabola, it is better to always write down some values for x and work out the values of y. So this time I have isolated y as 1 over 16x squared. Putting different values of x, we can get different values of y, and plotting them, we get our graph as shown here. So I hope these steps are clear. So in the first part, we have seen how do we find the parameters of a parabola when it is given in the standard form. So standard form really means that the vertex is at the origin. Now we are going to understand what happens when the parabola is transformed. So vertical and horizontal translations is what we are going to look into. Well, as you know about the translations, the points x and y for the vertex, if they change from 0, 0 to let's say vertex changes from 0, 0 to hk, it really means that along the horizontal it has moved h units, and along the vertical k units. That means h right and k up. So that is the kind of transformation of the vertex which has taken place. Now this will transform the equation also. Perfect. So we have the standard equation y square equals to 4px. Now, this y square equals to 4px can also be written as x is equals to 1 over 4p y square. So there are different forms in which you will see this particular equation. Now, what happens when we do the transformation? Well, clearly, when you do the transformation, in that case, the value of, if my equation, it all depends on whether the parabola is opening up or it is opening sideways, right? So we could have two conditions. One, it opens up, or it opens sideways, correct? And of course, sideways could be right or left, and up really means it could be up or down, right? So we could have both the conditions, up or down, and sideways also we could have moving right or left. When it is up, we take positive values, right? And when it is right, we take positive values. But when it is down or left, we take the negative values of P. Correct. That is kind of important to understand. Well, if the vertex is translated h units towards right and k up, in that case, using the transformation, the formula changes a bit. So basically, what happens is something like this. Let us say we have this formula y equals to 1 over 4p x whole square. So because of this translation, what is going to happen? Well, as you can see, y gets translated. So we can have y minus k equals to 1 over 4p x minus h whole square. So that gives you the transformed equation from the standard one once you know the vertex. Clear, right? So we have written it in different form, taking this k to the other side. So that is another standard way of writing our parabolas equation. So y can be written as 1 over 4p x minus h whole square plus k. So that really means the translation is h units to the right and k up, exactly same as we were thinking about. So that is how the vertex has changed to hk, right? That's the idea. So now the vertex is at hk, focus will be p above, right? So as we have seen p above, so the y value of k will be added by p. The x-axis this time, which was this x equals to h, will become the axis for the parabola, right? So that going through the vertex x value, vertical line, so that is a vertical line. So that becomes the axis. Directrix will be a horizontal line, right? P units below the vertex. So the k will now be subtracted by p to get y equals to k minus p as the directrix. Is that clear to you? So that is how we get our transformed equation. If it is opening to the right, in that case, the y minus k, from the y will take away k, plus h will become the equation for the parabola. Vertex now is at hk as before. However, it opens towards the right. Since it opens towards the right, focus moves further right, and therefore the value of focus will be h plus p, y value remaining same. The axis is horizontal, and therefore the horizontal value of k will be taken for y equals 2. The directrix will, however, be vertical. So for a vertical directrix, it will be x equals to h minus p, since it is on the left side of the vertex. Clear? So you could actually imagine in these ways and get all the equations. I'd like you to work out on what happens when the parabola opens down or when it is opening towards the left. We just have a negative sign in the above equations to take care of the reflections on the axis. So I hope that makes things absolutely clear. Well, let's look into a question. We'll take two more questions now based on the transformed equations to understand all the concepts. Is that clear to you? Here is example 3. The question is identify vertex, focus, axis of symmetry, and directrix for the given equation y equals to minus x minus 3 whole square plus 1. Correct. As you know, the standard form of the equation is y equals to 1 over 4p x minus h whole square plus k. Now, how are you going to solve it? Well, let's go in small steps. As clearly shown here, if you compare what is the value of p. So we'll begin from here itself. We know 1 over 4p is equal to minus 1. So p is equal to, we can just cross multiply minus 1 over 4. Right, so we get the value of p. Let's begin with the vertex first. Vertex is given by the translation from origin to the point. So we have the vertex v as 3 and plus 1, correct? So that becomes the vertex. The parabola, since it is y equals to minus, it opens downwards. So this parabola opens downwards. So when it is opening downwards, we now know that the vertex here is 3, 1, and the value of p is minus 1 over 4. So the focus will be right there. So as far as the focus goes, it is along the axis of symmetry, right? It is along the axis of symmetry, which is right there. So that means their x values are going to be same, right? However, the y value is going to change. So x value is 3, which is going to remain same as far as y value is concerned. Instead of 1, it has shifted down. So it will be minus 1 over 4, right? So you can write down the focus as what? Focus is 3, 4 minus 1 is equals to 3. Yeah, 4 minus 1 is 3, minus 3 by 4 is 3 by 4, right? So that is how we'll get the focus here. As far as the directrix goes, it is going to be above the vertex, same distance away. So it's a horizontal line. So we are looking at a horizontal line which passes through a point which is slightly higher than the vertex. So we'll get the line as y equals 2. Instead of 1, we'll add 1 over 4. So it becomes 5 over 4. Is that clear to you? So we get the directrix. So that is how very easily from the given conditions we can find all the results. I hope the steps are absolutely clear. Now let's look into a neater solution. Right here we have the parabola along with the equations which we were working with. So we began with the standard equation. When you compare this standard equation, 1 over 4p is minus 1, so p is minus 1 over 4. The vertex, as clearly shown, is at 3 and 1. Now, that is the vertex. Focus will be below the vertex, and therefore we'll do 1 minus 1 over 4, which gives us the value of the vertex as 3, and 4 minus 1 is 3, 3 over 4, correct? So that is this point which is shown here, which is going to be at, I should write focus F here, right? So the focus F is 3, 3 over 4. The axis of symmetry is the vertical line x equals to 3. Directrix is above, and that is the directrix which is y equals to 1/4 above 4, so 5 over 4, right? To sketch the graph, we'll just isolate y. It is already isolated. Substitute some values of x and calculate. So I chose the values of x as 2, 3, 4, and 5 and got the calculated values of y. Plotting these points, we get our line. Is that clear to you? So that is how we are going to sketch the parabola. So I hope the concepts are clear. Let us take one more example, which is going to be the last example. This parabola opens vertically downwards. Now here we'll take another example where the parabola is going to open horizontally, right, sideways. So the question here is identify vertex, focus, axis of symmetry, and directrix for the given parabola, which is minus 1 over 3 x minus 3 equals to y plus 5 whole square. I'd like you to pause the video at this stage, answer the question, and then look into my suggestions. Correct? Okay, so let's begin. The standard form you could also write as shown here. We can actually take 4p on the other side. Let me just remove this from here. Or we could take it either way it could work, right? So but we cannot write it on both the sides. So since it was written there, I wrote 4p on the left hand side, so cross multiply. So clearly what we have here is that 4p is equals to minus 1 over 3, or p is equals to minus 1 over 12. So that is what it is. Since we have negative here in this case, it means it is going to open left, right? Since we have this negative, it is going to open on the left side. Correct? The vertex is where? The vertex is at the y value being minus 5 and the x value being 3. So this is the vertex 3 and minus 5. So focal point will be on the left side along the axis. Axis is right there going through the y value of minus 5. So y equals to minus 5 is the axis. And since we are on minus 1 over 12, the focus, which is right there on this point, focus will be what? Focus will be the x value being 3. We have to do minus 1 over 12 to calculate the focus, y value being at minus 5. As far as the directrix goes, let me sketch that also here. Let's say this is the directrix, which is x equals 2. To 3 this time, we are going to add 1 out of 12. Clear? So that is how we are going to do. So this will be 12, 36, and 137 over 12. And here, the calculation will give us focus as 36 minus 1, which is 35 over 12 minus 5. Is this clear to you? So that is how very easily we can find all the parameters, correct? Here is a better solution for the same thing. I mean, solution is same but written, typed out. So if we began with the basic concept that the equation could be written as 4p x minus h equals to y minus k whole square. Comparing, we get 4p equals to minus 1 over 3, or p is minus 1 over 12. So the vertex is given directly from the equation, is at 3 minus 5. To find the focus, we will just take away 1 over 12, the value of p, and calculate. So we get 35 over 12 as discussed for the focus, right? So the focus is very close here to the graph, which is at 35 over 12 minus 5, correct? So that is what the focus is. Directrix will be on the right hand side. So this is the directrix, which is a vertical line, x equals to 3 plus 1 over 12, 36 plus 1 is 37, so x equals to 37 over 12. To find the other points, you can rearrange this equation and then calculate. So for different values of x, I have calculated the values of y, plot these points to get the graph, right? We know the vertex and the two x-intercepts in this particular case. We can say y equals to 0 and then calculate the values for x. So, in fact, the x equals to 0 and then calculate the values for y. So I hope you have understood And now from the given equation, which is minus 1 over 3 x minus, let me write down the equation here, minus 1 over 3 x minus 3 equals to y plus 5 whole square, we can calculate the value of y substituting the value of x. Good values to take is x equals to 3. That makes this as 0, right? So you get minus 5 as your answer. You could also look into x as 0. If I substitute x as 0, then I get here minus times minus is plus 1. Square root of plus 1 is plus and minus 1. And so we get plus and minus 1 equals to y plus 5. And that gives you two results. That is, y is minus 4 and minus 6. So those are the results for this particular graph. So you get the two y-intercepts. Perfect. So I hope you have understood how we could get the parameters and how can we sketch a parabola. So now let me summarize what did we do here. We began with understanding with some definitions, and clearly we understood that if we are talking about a parabola whose vertex is at the origin, then that is called the standard form. But in any case, any point on the parabola is actually same distance away from the focus point and a vertical line which is called directrix. Correct? And we have also understood few more terms as labeled here in this particular diagram. So basically, a parabola is the set of points whose distance from a focus is same as that from the directrix. Vertex is halfway between the focus and the directrix. So this is very important to understand. So vertex is always halfway between them. So parabolas could open up or down, right? Or could open sideways. That means left or right. So if we have a transformed parabola, that is to say, the vertex has shifted, translated to hk. In that case, the points will be as mentioned here. Is that clear to you? For both the kind of parabolas. So that becomes a key for you to understand the related formulae and how do we apply them. I hope you find it interesting and useful. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that will be great. Thanks for your time and all the best.